In this video, we will see introduction and exercise 14.1 and 14.2 of chapter Symmetry, Standard 7. Let us start our new chapter, Symmetry. Before starting this chapter, let us see the introduction, what point to be covered in this chapter. Let us see. First point is figure has a line symmetry if there is a line about which the figure may be folded so that the two part of the figure will coincide. Means take for example, take any figure, and if you draw a line from the center of such figure, and when you will fold such figure, that both the parts should be coincide to each other. Means take for example, see here the pictures, few pictures are given. Architecture, when we will draw a line of symmetry from here, because line of symmetry is not possible from here because top and bottom are different. So when we will draw a line from the center of this figure, when we will fold this figure, both the part, means both the parts should coincide, it should cover each other completely. Same in the car also, engineering car. See, if you will draw a line from the center, when you will fold the figure, it should coincide to each other. Here this, see here, when you will draw a line, when you will fold the figure, it should coincide to each other. So this is known as line of symmetry. Means it says that the particular figure evolve line of symmetry. Now the regular polygon. Now regular polygon has equal side, as we all know. Whether if you take any triangle, square, rectangle, pentagon, octagon, hexagon, it should be a regular. Rectangle cannot be regular because it has a length and breadth. Square can be regular. So they have multiple or more than one line of symmetry. Take for example over here, see, these are few example of regular polygon. This is a regular, that is equilateral triangle. This is a square, regular pentagon, regular hexagon. See here, triangle has three sides, means three line of symmetry we can pass. If you pass from here, when you will fold such figure, you will get equal part, that is both the part are coincide to each other. When you will draw a line from here, when you will fold the figure, both the part will coincide to each other. When you will draw a line from the center, when you will fold the figure, you will get both the part coincide to each other. Same way here also, from the center to diagonal you can draw, from this through this, when you will fold, you will get both the part coincide to each other. See here, regular pentagon has 1 2 3 4 5 equal part. Square 1 2 3 4 equal line of symmetry, and hexagon 1 2 3 4 5 6 equal part. So this is written over here, that is number of line of symmetry. Hexagon has 6 equal line of symmetry, pentagon has 5, square has 4, equilateral triangle has 3. Now the mirror reflection. What is the mirror reflection? Mirror reflection lead to symmetry only under the condition if left and right orientation have to be taken care of. Means whatever the image, take for example over here, if letter A, in front of letter A, if in the center, if you put one mirror, so its reflection falls like this, means both left and right look similar. Now if we take another example, if we see R, when you put a mirror in front of R, it will not look similar. The right and left combination, see here a monkey, it not look similar, they are facing toward opposite direction. Here are also facing toward opposite direction. So in mirror reflection, the image should be look exactly the same, its reflection should be fall same. Next point is rotation turns an object about a fixed point. Now if we see, if we turn any object, means a fixed point is the center of the rotation. Fixed point should be there at the center. The angle by which the object rotates is the angle of rotation. Now the half turn means rotation by 180, a quarter turn means the rotation by 90 degree. A rotation may be clockwise or anti-clockwise. Now if after a rotation an object look exactly the same, we say that it is a rotational symmetry. Means an incomplete turn of 360 degree, the number of time an object looks exactly the same is called the order of rotational symmetry. For example, the order of symmetry of a square is 4 while an equilateral triangle is 3. Means from square has 4 right angle, from all its direction it look right angle only, 90 degree only, and in equilateral triangle the sum of measure of all angles of triangle is 180 degree and each angle is 60 degree. Means in 3 rotation the equilateral triangle looks similar only. Let us see with the figure. See here, one example is over here, given over here, A, B, C, D. Here in each rotation is of 90 degree. So in one rotation you will get now in first rotation the A will come over here and B will go over there. Second rotation A will come over here and D will come down, and in third rotation C will come down and D will go up, and in last rotation B will come down and C will go up. So 1, 2, 3, 4. In 4 rotation it will come to its original position, and in each rotation its look similar only. See the another example. See, it is also an example of a square only. When we will turn it anti-clockwise, so this 90 will come down, then it will go over here, again it will come, and again it will come to its original position. So in 4 rotation it will come to its original position, and if we see, so we can say that each angle is of 90 degree. Next one, some shape have only one line of symmetry. Take for example like letter E. Letter E has only one line of symmetry like this. If we pass a line of symmetry from the center, when we will fold, both the shape will coincide to each other, upper part and lower part. Some have only rotational symmetry like letter S. Here we can't draw a line of symmetry. It has rotational symmetry. When we will turn first, then again second, third, fourth time when you will turn, it will get back to its original position. And some have both symmetry and rotational like H. Means from here when you will pass line from the horizontally, vertically or horizontally, you will find a line of symmetry, and when you will turn also upside down, you will find rotational symmetry. So that we will see in the exercise. The study of symmetry is important because of its frequent use in day-to-day life, and more because of beautiful design it can provide us. So let us see the exercise. Let us start our exercise 14.1. Copy the figure with punch hole and find the axis of symmetry for the following. Now we have to find the axis of symmetry. So here the few figures are there with a punch hole, and you have to draw the line of symmetry. So in the first figure 2 punch hole is there, so one line horizontally and one line vertical. So we will get 2 line of symmetry. See in this way. The second one is here 2 punch hole is there. So from where you will pass the line of symmetry, here if you will pass, so both the part will not have punch hole. So here you have to draw a line of symmetry from the center of the punch hole. See here, only one line of symmetry. Then here also you have to pass a horizontal line. See here. Then here also you have to pass a horizontal line. Then here, dear student, you can pass 1, 2, 3 and 4 way lines. Then here it is, one figure is there. So horizontal line you can't draw, vertical you can draw one line of symmetry. This also you can't draw, diagonal also, because if you draw a diagonal, so another hole will remain. Here from the center, see here, and here horizontal line you have to draw, and here also vertical line, here vertical, again vertical and horizontal also possible, here also horizontal and vertical both possible, and the diameter also from the center of this punch hole. And here only one vertical line is possible, no horizontal, because if you draw horizontal line, the upper part will have one punch hole but lower part is not having. So this is how you have to draw your figure. First you have to draw the question, then you have to draw the line of symmetry in the figure. Question number 2, given the line of symmetry, find the other hole. Now see here, the line of symmetry is given. We just need to draw another hole. If one hole is there in the lower part, another hole will come over here, to draw it over here. See here, one hole is in the upper part, another hole will come in the lower part. See here, one hole is over in the half of the triangle, so another hole will come over here, punch hole. Yes, see, one hole in the upper semicircle, the another hole will come over here. See over here. Then one dot is over here, another dot is over here. Now what will see? So what we will do? So its symmetry will come over here and its symmetry will come over here. So see, this is how you have to draw the figure. Now, the next question. In the following figure, the mirror line is given as a dotted line. Complete each figure performing the reflection in the dotted line. You might perhaps place a mirror along the dotted line and look into the mirror for the image. Are you able to recall the name of the figure you completed? Now see here, one figure is there. You consider you have to think that that dotted line is one kind of a mirror. Now what I will do, you have to draw the mirror image. So its mirror image will be like this only, that is square. Its mirror image is a triangle. Its mirror image, see, it's like a rhombus. Its mirror image like a circle we got. Its mirror image we got a pentagon. Its mirror image we got hexagon. 1 2 3 4 5 6 7 8 octagon, sorry. Next question. The following figure have more than one line of symmetry. Such figures are said to have multiple line of symmetry. Now such figures are given. We have to find that multiple line of symmetry. So if you observe the figure minutely, see here, one inside it is a triangle. So 3 line of symmetry we will get 1 2 3, which divide the figure into 2 equal half. Now here means mirror image should be fold. When you will fold the figure, it should, both the parts should coincide to each other. Means from here if you will fold, it will coincide. From here it will fold, it will coincide to each other. Yeah, triangle also, triangle again have a 3 sides. So from 3 sides means from the center it will coincide. From here also it will coincide. From center also it will coincide. Now square has a 4 sides, so 4 line of symmetry, 2 diagonal and 1 horizontal and 1 vertical. So from all 4 side, 4 line of symmetry means from all 4 side, when you will fold, you will get line of symmetry, means both the part will coincide to each other. See here, only one way is possible, when you will pass up from the center, line of symmetry from the center. From this way not possible. When you will draw horizontal, it is not possible, only the vertical line is possible. Here again inside it is a square, means 4 line of symmetry you will get, 2 diagonal and 1 horizontal and 1 vertical. Now here see how many, first you have to count a number of circle, 1 2 3 4 5 6. So 6 line of symmetry you will get. So see, I had divided exactly from the center of this, whatever that petals like structure is given, from the center you have to draw one straight. See here, so 6 line of symmetry you will get, 1 2 3 4 5 6 line of symmetry. Now this is inside the square. So here if you observe, only the diagonal is possible, no vertical and horizontal, because the figures shows such. When you will draw a vertical line, so both you will not get a mirror image. When you will draw diagonal from both, when you will fold, both the image coincide to each other, upper and lower part. When you will draw a diagonal like this, when you will fold in this way, so both the figure will coincide to each other. Next question, copy the figure given here, take any one diagonal as a line of symmetry and set a few more squared to make the figure symmetric about diagonal. Is there more than one way to do that? Will the figure be symmetry about both the diagonal? Let us see. See here, one kind of figure is there. See, and you just need to draw a diagonal which divide the square into 2 equal half. So one side is over there. So when we will fold the figure from, when we will join A to C, so its mirror image will come over here, and mirror image of E will fall on H. So now yes, there is a more than one way to make the figure symmetry. Now let us take the diagonal BD and shade the square shown in the figure, to make the figure symmetry to BD. Now see, when you will fold from here, so see, its mirror image will fall over here. Similarly, the figure is symmetry about diagonal AC also. From here also, when you will join D to B, its mirror image will fall over here, its mirror image will fall over here. So thus the figure is symmetry about both the diagonal. The figure is symmetry about EF and GF. See, E F and E to F and G to H. Now, question number 6 we will do in textbook. It is activity based. Let us see. Question number 6. See here. Copy the diagram and complete each part to be symmetry about the mirror line. See, one kind of a line is given in the figure. Line of symmetry is also given. So, its mirror image will fall like this. Now, the next one is given upper part. So, you have to draw its lower part. You have to draw exactly its mirror image. And upper part is given. So, its mirror image will fall like this. Now, let us see question number 7. State the number of line of symmetry for the following figure. An equilateral triangle. As equilateral triangle means 3 sides means 3 line of symmetry. One that vertical line. Then from here means from vertices you have to pass a line from the vertex to its opposite side. From the vertex of its to its opposite side. And from all the vertexes to the middle of the opposite side, middle of it opposite side. So you will get 3 line of symmetry. Then the next figure is here's isosceles triangle means 2 sides same means here only one vertical line is possible. From here it is not possible. Only one line of symmetry because when you will fold the figure you will get both the part coincide to each other. Scalens here no line of symmetry. Why? Because from anywhere you will pass the line you will not get a mirror image. Square means 2 diagonal, 1 horizontal and 1 vertical means 4 line of symmetry. Rectangle means only 2, no diagonal because vertical and horizontal line is possible because no diagonal because when you will fold through the diagonal you will not get the mirror image. Then the rhombus again through the diagonal only means 2 line of symmetry. Parallelogram again horizontal and vertical not possible, diagonal also not possible means 0 line of symmetry. Quadrilateral, any quadrilateral not possible. When you will pass through any way line of symmetry horizontal or vertical you will not get a mirror image. Regular hexagon means 6 side, hexagon means 6 line of symmetry you will get. Dear student, here all the sides should be same. Here it is not same, that is why you are not getting any line of symmetry. Here all sides are same, length of all the line segment. Regular means all sides are same. So you will get 6 line of symmetry. Circle, infinite many line of symmetry means from anywhere you pass you will get many line of symmetry. Infinite many line of symmetry. Now question number 8. What letter of English alphabet have reflection symmetry, that is symmetry reflected to mirror? Reflection about means it should look same. Vertical mirror means when we will pass a straight standing line. So through A it will look similar, H also, I from the center, M, O, T, U, V, W, X and Y. Through this letter you will get vertical image. Horizontal image, so through B, C, D, E, H, I, O and X you will get horizontal image. Both horizontal and vertical. H, see here and here, I through here and here, O also and X also, both line of symmetry. Now give 3 example of shape which with no line of symmetry, means through F you will not get any line of symmetry, vertical also or horizontal also you will not get from F, G and J. And or a scalene triangle, as just now only we saw scalene triangle whose all 3 sides are different, or parallelogram just now only we saw. Through such you will not get any line of symmetry. In that only 10th one, what other name can you give to the line of symmetry? Means to an isosceles triangle. Isosceles triangle means 2 sides are same. When you will draw a line of symmetry, what other name you can give? You can give a median, means which divide a triangle into 2 equal half. It is known as a median. Through a circle means whenever any line of symmetry pass through the center of the circle, it is divided into 2 equal half. So means whenever the line passes through the center of the circle, it is known as diameter. The other name, whenever the line of symmetry passes through the center of the circle, it is known as diameter. And for the triangle, it is known as median. Let us see exercise 14.2. Which of the following figure have rotational symmetry of order more than 1? means in one rotation only the figure should be look similar. Means if we see the, if we observe this circle in one rotation only it looks similar, means it in rotation, this also in one rotation only it will look similar. But when you will rotate this one, I don't think that you will get in similar image in one rotation. Means in when in first rotation it will come over here, then in second rotation it will face this side, then in third rotation it will face up, then in fourth rotation it will come back to its original position. So in one rotation it will not get back to its original position. Here also possible, when you will in one rotation only it will come back to its original position upside down. Here also in one rotation only it looks similar to its original position. Here also in one rotation it will look to its original position. So we can say that figure number A, B, D, E, F have the rotational symmetry of order more than 1. They all are having a rotational symmetry, means in one rotation only they look similar. In the next question, give the order of rotation symmetry for each figure. Now see, if we see in this figure, in one rotation this will come over here, and in second rotation it will get back to its original position. So in two rotation it will get back to its original position. Here also in first rotation it will come over here, in second rotation it will come over here, and vertical opposite angles are always equal. So in two rotation it will get back to it. It look like similar to its original position. Here triangle has three vertices. So in three rotation it will get back to its original position. Four petals like structure, or you can say wings of a fan. So in four rotation it will get back to its original position. When we will put a number 1, 2, 3, 4, in one rotation one will come over here, two rotation, second rotation one will come over here, third rotation one will come over here, and fourth rotation one will come back to its original position. Here also see four wings like. So in four rotation it will come back to its original position. It is a regular pentagon. So in 5 rotation it will get back to its order of rotational symmetry. Count number of, see, 1, 2, 3, 4, 5, 6. 6 corners, means in 6 rotation it will come back to its original position. Here how many legs are there? 3. So in 3 rotation it will get back to its original position.